Today it's super easy. And I just want to say, like, we're like, oh, super close. Oh, good. How exciting. This end of the semester is near. We have notes today, it looks like, and notes on Wednesday, and then that looks like the end. Hallelujah. So a review and a test, and then you guys are reviewing for your final. Okay. So that is on the docket. Oh, I don't have a calculator. All right. So today we're talking about the Triangle Proportionality theorems, which I think the better name for them are side splitter theorems, but they involve parallel lines. So parallel line, side splitter theorem. And so what they boil down to is, you'll notice all these pictures, we have nested triangles, right? We have the baby triangle and then the big triangle, and they're one on top of the other, nested inside one another. And you can see by this picture here, we have parallel lines. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So if segment DE is parallel to segment AC, as we have here in this picture, then we can say that these little sides, like side BD here, BD over this lower side, DA, BD over DA is equal to, again, our little pieces of sides here, BE over EC. So those parallel lines cut the sides of our triangle proportionally, okay? And so we can just do like little piece over lower piece, top over bottom, like you just get a right little proportion. So it's super duper easy. The converse is also true if you have proportional sides. So if BD over DA is equal to BE over EC. So if our ratios of the sides are equal, then we must also know that the lines are parallel. So DE is parallel to segment AC. So that's what we've got. So it's important that we remember if we have parallel lines or not. All of these pictures show parallel lines, but in Delta Math, they're going to show you pictures that require a little bit more interpretation. So you might see a picture like this in Delta Math. So we have our big triangle, and it appears maybe we have parallel lines, but all they're giving me are two congruent angles right there. So here's what we would see in Delta Math. What do we learn when they've given us these two congruent angles? They're corresponding. Hey, if corresponding angles are congruent, what do we know that we must have? Well, that's clear. They're marked congruent. What? No. Parallel lines. Yeah, that was the converse of all of our parallel line theorems. So then we must have these two lines being parallel. All right? So they gave us corresponding angles, so we know we must have parallel lines. So now we know we have parallel lines, and we can apply our little side splitter theorem. Okay? So we want to find the value of x here. Do we have parallel lines? So what ratios could we write? There's lots of ways to do it. So this thing is just twisted around, right? You can rotate that a little bit, and then it's arranged just like this. We could do it that way. You could do 14 over x is equal to 12 over 15. If we followed this picture, we would write 12 over 14 is equal to 15 over x. Are these the same? Do we get different answers? They're set up differently. They're the same, aren't they? How come? You just cross multiply and you're going to get the same thing. There's a billion ways to do it right and one way to do it wrong. Okay? So we did little piece over little piece and top piece over top piece. Or you can do, this right over left and right over left. It all works. It's kind of amazing. I love proportions. All right. So there's our setup. We can cross multiply. 12 times x is 12x. And 14 times 15. 14 times 15 is 210. And then I'm going to divide by 12. And I get x equals 17.5. Cool. Questions on that? All right. Let's just set up number 2. How would you set up first, do we have parallel lines? Yes. Okay. So how can we write our side splitter proportion? Be brave. Okay, that's the one wrong way to do it. Thank you. Thank you. But you can start with 18 over x, then 21 over 56. Oh, okay. So what you did, you said 18 over x and then 56 over 21, which is no good. 18, we got this little section over this bigger side. So we want to set up the same little section over the bigger section, okay? So you want to see some sort of pattern there. All right, then you can cross multiply. Let's look at number 3. Do we have parallel lines? Yeah. Do I have all my little side split segment lengths? No. Not quite. We need to do a little interpretation here. What is this little split segment length here? 55 minus 45. 55 minus 45, which would just give me a 10 there. Perfect. All right, so now I know that my little side segment pieces, the little pieces, now I can set up my proportion. What do we want to set up for a proportion? What can we do? And over 36, and then... No, that's the one wrong way. X over 36, sure, we can do x over 36 is equal to 10 over 45. That'll do. X over 36, little piece over bigger segment, and then little corresponding little segment over corresponding big segment. That's one way to do it. Is there another way you could do it? Yeah, what's another way? No problem. You could go straight across. We could go x over 10. So here are corresponding sides right there. We could have x over 10, and that would be the same as going across in the same manner, 36 over 45. This would also yield the same thing. All right? Number 4, what should we do? Subtract 6 from 27. Good, because we want the small segment lengths here, so that would give me 21. We have parallel lines, so we can use our little side splitter. What can we do for our side splitter here? Little proportion. 7 over x is equal to 6 over 21. Perfect. 6 over 21. Yeah, so we have this little piece over larger side and then little piece over larger segment. So, nice pattern there. Good. All right, we're not going crossways. We're not crossing the sides. All right. Let's look at 5. We have parallel lines, so what can we do for our proportion here?
30 over 25 and x plus 7 over 15.
Yeah, x plus 7 over 15. So you set it up just side to side here. So 30 over 25, beautiful, and then x plus 7 over 15, which is perfect. The other thing that's really nice is 30 over 25. Can I reduce that? Yeah. I can divide that by 5. 30 divided by 5 is 6, and 25 divided by 5 is 5. So my numbers are a lot smaller, and now I can use that. We're going to go ahead and solve this one. So I'm going to cross multiply. So I have 5 times the x plus 7, so I have to distribute my 5. And I have 15 times 6. 6 times 15 is 90. And then I can go ahead and distribute my 5. So that gives me 5x plus 35 equals 90. And I can subtract the 35. So 5x equals 55, which means x equals 11. Okay? Pretty good? All right, cool. Any questions so far? All right. Let's turn the page. We're going to skip down to more. This is an extension of the side splitter. How many parallel lines do you see? 3. But you can imagine this parallel line at the top wasn't there. We would have 2 parallel lines, and these transversals right here would extend and form triangles, right? So imagine that top one wasn't there. Then we would have the exact same picture we were just looking at, where we had a triangle within a triangle, 2 parallel lines. Is it the same picture as before? It's pretty darn close. It's just that the lines go on. They don't stop in triangle shapes, right? Okay, so we have the same thing. And that's why we can just sort of say, hey, if it was true before, anytime we have parallel lines, they are going to get divided proportionally, cut up in proportional ways. And so, if we have AB, parallel, segment AB, or in this case line AB, I guess is what it is, parallel to line CD, and that is parallel to line EF. So we have all these parallel lines cutting 2 transversals. It's going to cut things up in a proportional way. So I can think, hey, AC over CE. AC over CE. So that's the left little pieces, those little segment lengths, is going to be equal to what over what? BD, segment BD, over DF. Yes, DF. And this I'm using little shapes. So this was just top over bottom is equal to top over bottom. But the same would be true. I could also do AC over BD is equal to CF over DF. Like you can go across as well instead of just top and bottom, top and bottom. All right, so it's the same thing. Parallel lines cut things proportionally. So how can we set up number 10?
18 over 45 and then x over 52.
That works. 18 over 45 would be proportional to x over 52. That totally works. You went bottom top is equal to bottom top on the other side. That works too. And then we would do what from there? Cross multiply. Good. And I'm not going to do that because we're very good at that. All right, number 11, how would we set that up? Or what's one way we could set it up, really? There's
over x and 12 over 30?
Yes. 14 over x is equal to 12 over 30. And so on that one, you went sort of top over bottom and top over bottom piece. All right. If you imagine I'm turning my paper a little bit. Top over bottom, top over bottom. That works. Perfect. All right. Clayton, you got a confused look on your face. You got it?
Yeah.
Yeah? Okay. What should we do with number 12?
Minus 18 from
Yep, subtract 18 from 32. I don't know. 14. Oh, that makes sense. Good. All right, we definitely always need the little parts for this. So then, what can we do to set this one up?
14 over 18 and x over 27.
Sure. 14 over 18 and x over 27. Could you reduce the 14 and the 18 to make your life easier? Yeah. Absolutely. Okay. But we have calculators, so who really cares? What should we do for 13?
Minus 28,
92 minus 28. Beautiful. 28. Turns out to be 64 for that little section. And then we can set up what?
28 over 64 and 31.5 over x.
Beautiful. Cool. Have we got the hang of this? All right, we're going to do number 14, then we're going to be done. We got our little sections here. What can we do for our proportion? 3x plus 1 over 12. 24 over 18 equals 3x plus 1 over 12. I want to reduce the 24 and the 18. We can divide by 6. If I divide by 6, my numbers are smaller. That's going to give me 4 over 3, which is very helpful. And then we can cross multiply. So I'm going to do 3 times the entire 3x plus 1. What is 3 times the entire 3x plus 1? 9x plus 3. Beautiful. And then we're going to do 12 times the 4, which is 48. I can subtract the 3. 48 minus 3 is 45. And then divide by 9, we get 5. All right, ladies and gentlemen, do you have any questions for me? All right, you have adults math. The first couple are really, really easy. It does go a little bit of review from what we did yesterday of proving triangles similar. And then the last part is setting up proportions. Again, so when you're setting up proportions, you need to look. Am I the whole side and the whole side? Little piece and little piece. You got to keep them nicely organized, paying attention to your drawing.